A dwarf planet is a type of celestial body that orbits the Sun and has specific characteristics that distinguish it from a full fledged planet. Pluto is a dwarf planet located in the outer regions of our solar system. It is the most well known and historically significant dwarf planet. Previously considered the ninth planet, Pluto was reclassified as a dwarf planet in 2006. Pluto's orbit is eccentric and inclined compared to the eight planets' orbits, leading to occasional periods where it is closer to the Sun than Neptune. One of the notable features of Pluto is its small size. It has a diameter of about 2,376 kilometers, 1,476 miles, making it significantly smaller than Earth's moon and several other moons in the solar system. Its size, along with discrepancies in its orbit, prompted the reclassification of Pluto as a dwarf planet. Currently, there are five known dwarf planets in our solar system: Pluto, Eris, Haumea, Makemake, and Ceres. Ceres is a dwarf planet and the largest object in the asteroid belt, a region located between Mars and Jupiter. It was the first dwarf planet to be discovered and holds a significant place in our understanding of the solar system's formation and evolution. Ceres was discovered by Giuseppe Piazzi on January 1, 1801, initially classified as a planet. It was later reclassified as an asteroid as more objects were discovered in the same region. Finally, in 2006, Ceres was declared as a dwarf planet. Some key features of Ceres include its size and composition. It has a diameter of about 940 kilometers, 585 miles, making it the largest object in the asteroid belt. Ceres is spherical and has a rocky core with a mixture of water and ice in its mantle. In fact, Ceres may contain more fresh water than Earth. Ceres is also known for its diverse geology. It has mountains, craters, and unique features such as bright and dark regions on its surface. These characteristics provide valuable insights into the history and formation of Ceres and the early solar system. Studying Ceres and its composition helps scientists understand the processes that occur during the formation of the solar system, as it represents a preserved relic from the time. It also sheds light on the distribution of water and organic materials which are essential for the development of life as we know it. Pluto is a dwarf planet located in the outer reaches of our solar system. It was once considered the ninth planet but was reclassified as a dwarf planet in 2006. Pluto's surface is made up of a variety of ices, including nitrogen, methane, and carbon monoxide, along with rock. The surface also features mountains, plains, and other geological formations. Pluto has a thin atmosphere consisting primarily of nitrogen and traces of methane and carbon monoxide. This atmosphere was first detected in 1988 when Pluto was passing in front of a star, causing a dimming effect. The study of Pluto has provided valuable insights into the outer regions of our solar system and the processes that shaped it. It has deepened our understanding of icy worlds and the diversity of celestial bodies with our cosmic neighborhood. Pluto continues to be an object of fascination and exploration with the potential for further discoveries and insights in the future. Eris is a dwarf planet located in the outer regions of our solar system. It was discovered in 2005 and played a significant role in the reclassification of Pluto as a dwarf planet by the International Astronomical Union (IAU). Eris is named after the Greek goddess of strife and discord. Its discovery led to a major debate among astronomers about the definition of a planet, eventually resulting in the IAU's decision to reclassify Pluto. It is one of the largest known dwarf planets with a diameter of about 2,326 kilometers, 1,445 miles. Eris is located in the scattered disk, a region beyond the Kuiper belt that is populated by many icy objects. One interesting feature of Eris is its highly eccentric orbit. It takes approximately 557 Earth years to complete one orbit around the Sun, making it one of the most distant objects in our solar system. Eris is composed primarily of rock and ice similar to other objects in the outer regions of the solar system. Its surface is believed to be covered in nitrogen and methane ice. Like Pluto, Eris has a moon called Dysnomia, which was discovered in 2005. Dysnomia is relatively small compared to Eris, with a diameter estimated to be less than 350 kilometers, 217 miles. Studying Eris and other dwarf planets in the outer solar system provides valuable insights into the formation and evolution of our solar system. These objects represent remnants of the early stages of our cosmic neighborhood and holds clues about the processes that occurred billions of years ago. Haumea is a dwarf planet located in the outer regions of our solar system. It was discovered in 2004 and named after a Hawaiian goddess. Haumea is an intriguing object as it has a unique shape. It is elongated and resembles an elongated ellipsoid or rugby ball. This shape is believed to be a result of its rapid rotation, which causes it to flatten at the poles and bulge at the equator. The diameter of Haumea varies depending on its long axis, around 200-320 kilometers or 140 miles, and its short axis, around 100-620 kilometers or 1010 miles. It is one of the largest objects in the Kuiper Belt, a region beyond Neptune that is populated by icy objects. Haumea has a highly eccentric orbit with an average distance from the Sun of about 43 astronomical units. 1 AU is the average distance between the Sun and Earth. It takes about 284 Earth years to complete one orbit around the Sun. Similar to other dwarf planets, Haumea is composed of rock and ice. Its surface is believed to be covered in a layer of crystalline water ice. Haumea's rapid rotation causes it to have a unique surface feature known as tessellation, which appears as a pattern of bright and dark regions. Makemake is a dwarf planet located in the outer regions of our solar system. It was discovered in 2005 and its name comes from the creation deity in the mythology of the Rapa Nui people of Easterland. Makemake is one of the largest known objects in the Kuiper Belt, a region beyond Neptune that is filled with small icy bodies. It has a diameter of approximately 1,430 kilometers, 890 miles, making it slightly smaller than Pluto and Eris. One of the notable features of Makemake is its bright surface. It reflects a significant amount of sunlight, indicating the presence of ices such as methane, ethane, and nitrogen. These ices likely contribute to the bright appearance of the dwarf planet. Makemake has a highly elongated and inclined orbit similar to the other dwarf planets in the outer solar system. It takes about 309 Earth years to complete one orbit around the Sun, making its journey around the Sun quite lengthy. Due to its distance from the Sun and the limitations of telescopic observations from Earth, our knowledge of Makemake is somewhat limited. However, scientists have been able to gather information about its surface composition and study its atmosphere. One of the key differences between dwarf planets and planets is their size. Dwarf planets are generally smaller. The classification of dwarf planets was introduced by the International Astronomical Union in 2006. The IAU defines a dwarf planet as a celestial body which orbits the Sun and is spherical but does not clear its orbit out of debris. Dwarf planets can also have moons just like other planets. For example, Pluto has 5 known moons. Pluto's largest moon, Charon, is so big that some scientists consider it as a binary system rather than a moon. Dwarf planets are often found in regions where there is a large concentration of asteroids, such as the Kuiper Belt. The Kuiper Belt is a region beyond Neptune where a lot of icy bodies, including dwarf planets, are located. Dwarf planets are made up of lot of materials like ice, rock, and organic compounds. Ceres, the largest dwarf planet in our solar system, is composed of rock and ice, with a rocky core and an icy mantle. Pluto and Eris, on the other hand, are predominantly composed of nitrogen ice. The reclassification of Pluto as a dwarf planet sparked a debate among astronomers and the general public about the definition of a planet. Some argue that the definition of a planet should not be just based on size, but it should also be based on other factors. Some argue that the definition of a planet should not be just based on size, but it should also be based on other factors. Some argue that the definition of a planet should not be just based on size, but it should also be based on other factors. Some argue that the classification of dwarf planets has led to a more detailed understanding of the diversity of objects in our solar system. The study of dwarf planets has shed light on the processes that shape and reshape celestial bodies over time. Dwarf planets can provide valuable information about the history and evolution of our own planet. The exploration of dwarf planets has been a focus of numerous space missions, including NASA's New Horizons mission to Pluto. The New Horizons mission provided unprecedented close up images and data about Pluto and its moons. The spacecraft revealed a diverse landscape on Pluto, including mountains, valleys, and icy plains. The discovery of nitrogen glaciers and flowing nitrogen ice on Pluto was particularly surprising to the scientists. The data collected by New Horizons has revolutionized our understanding of dwarf planets and their geological processes. The exploration of Eris, Haumea, and Makemake is still limited, but future missions may provide valuable insights into these dwarf planets. The study of dwarf planets extends beyond our solar system. Astronomers have identified dwarf planets orbiting other stars. These distant dwarf planets, known as exoplanets, offer a glimpse into the diversity of planetary systems in the universe. The search for exoplanets and dwarf planets is an ongoing effort utilizing advanced telescopes and space based observations. Dwarf planets are often referred to as minor planets or planetoids due to their size and status in the planetary classification system. The term dwarf planet is not meant to diminish the significance of these celestial bodies but to categorize them based on specific criteria. Dwarf planets can have complex orbits interacting with other objects in their vicinity. This dynamic orbital behavior can lead to interactions and collisions between dwarf planets and other celestial bodies. The collision between two dwarf planets can result in the formation of a new larger celestial body. And there you have it, a glimpse into the fascinating world of dwarf planets from Pluto, which sparked a reclassification debate, to Eris with its highly eccentric orbit and Haumea and its unique shape. These celestial bodies are full of wonders waiting to be explored. Dwarf planets provide us with valuable insights into the formation and evolution of our solar system. They remind us that there is more to our cosmic neighborhood than meets the eye, with hidden icy worlds and mysteries waiting to be unraveled. As our knowledge grows and technology advances, we are continuously discovering new dwarf planets and expanding our understanding of these far off objects. Each one offers its own story, its own composition, and its own place in the intricate tapestry of our universe.